If you can't find a seat, oops, sorry, that was loud. If you can't find a seat in the back, there's a balcony right above us. So go back out, turn to the right, go through a set of double doors. I think it says balcony or something, and plenty of seats up there. There are also a few seats there's one here, a couple over there, one over there, a few here and there, but there's a bunch up there. So, balcony. Okay, again, if you're looking for a seat, I think the main floor is pretty much full. There are a couple of seats in the front, but there's a balcony right above us. There's lots of seats up there. Okay, it's time to start. So, good morning. Good. For those of you returning, welcome back. For those of you new to Purdue, welcome to Purdue. This is Math 261. My name is Dr. Joseph Chen. I'll be your instructor this semester. My office is in the Mathematical Sciences building. It's abbreviated MATH, M-A-T-H, room 848. My email is chenjk@purdue.edu. Office hours, officially Monday, Wednesday, Friday, 9 to 11 a.m. But basically, whenever I'm in my office with my door open, you are free to come in and talk to me and ask questions. If you want to see me and you want to make sure I'm there and it's outside my official office hours, send me an email. Let me know when you prefer to meet, and I'll try to arrange my schedule to meet with you. The course web page right here, math.purdue.edu/MA261, contains all the information you need to know about the course. And let me show you what it looks like. It's a very standard math course page. I'm sure many of you have seen this before. Posted on here are the ground rules, the syllabus, assignment sheet, and the course calendar. Let me just show you what they look like. Here are the ground rules. I'll go through the main points of this in my PowerPoint presentation in a few minutes, but be sure you at least skim over this thing. Assignment sheet, course calendar, tells you what each day we'll be doing, when the quizzes are, and all that good stuff, and when the exams are, and so on. All right, back to this. So I'm going to go through the main points of the course policy, structure, and rules that are listed in the course ground rules document. You have to read that document. It's your responsibility to understand all the rules and all the procedures and all that. But I'll go through the main points here. Once again, you can find that at math.purdue.edu/MA261. Textbook. For most of you, this is probably very familiar. We'll be using the same textbook you had in 161, 2, 6, 5, or 6. James Stewart, 7th edition, early transcendental. Big, heavy monstrosity. You need access to webassign. And for most of you, if you took Math 161, 2, 5, and 6, the account that you used last time is still good, as long as you have purchased the multi-term access. All right? So just check it out. If it lets you in, then you are good. See the course webpage for more information about webassign and textbook. Now, if you are new to Purdue, you don't have a webassign account yet, you can start doing work right away. Webassign gives you a 2-week trial period during which you don't have to pay anything. So right after class today, go to the course webpage, click on the webassign login link in the middle of that page, and you can start doing homework right away. The first 2 weeks, you don't have to pay anything. After that, you'll have to pay the non-refundable access fee. As of August 12th, the single-term price is $94. Life of edition is $125. And what comes with webassign besides the homework is the ebook. So if you don't want to carry this 5, 6, 7, 8, 9 pound book around, the ebook is on webassign. And I will probably stop carrying that now. This is quite a bit of work. Okay, so webassign gives you that very nice ebook that you can look up. If you have questions about webassign, send me an email. I know a few things about webassign, so I'll try to help you. And once you get into webassign, you can purchase for webassign access directly from webassign during the 2-week trial period. Calculator policy is very simple. No calculators. End of story. On exams and quizzes, on homework, sometimes there are numbers that are not very nice, so feel free to use calculators on homework. But on exams and quizzes, no calculators whatsoever. Homework and quizzes, there will be 37 online assignments using webassign. The login here is webassign.net/purdue/login.html. There is a link in the middle of the course web page that takes you directly there. Don't go through webassign directly. Make sure you go through the webassign Purdue portal listed here, or click on the link in the middle of the course web page. Homework from the Friday and Monday lectures are due Tuesday at 11 p.m., except the first homework. The first homework is actually due Thursday instead of tomorrow. This will give you a little bit of time to get things together if you are still trying to get into the course, for example. So the first homework is actually due Thursday, not tomorrow. Homework from the Wednesday lecture is due Thursday at 11 p.m. There are a few handwritten homework from the assignment sheet. Let me show you. Here. So this is on the course web page. As you can see, a few of these problems are listed here in bold. These are not on webassign for various reasons. Sometimes they deal with graphing. Sometimes they have other reasons why they're not on webassign. You're still required to do that, but you are not required to turn this into anybody. And of course, on exams and quizzes, we will cover everything that over all the material on the homework, including these handwritten homework assignments. All right, so once again, those are not collected, but you're responsible for the material covered. No late homework is accepted for any reason, but we do excuse the lowest 3. There's a quiz in almost every recitation class on the lessons from the previous week, except this week. See the course calendar, which right here. All right, so the yellow ones are the recitation. So quiz 1 is next Tuesday. No makeup quizzes will be given for any reason, just like homework. But also, again, we drop the lowest 3 quiz scores at the end of the semester. Exams. There are 2 exams. This is different from Math 161 to 5 and 6. Back then you had 3. Here you have 2. They're both 1-hour multiple choice exam. The first one is on Thursday, September 29, 6:30 p.m. at Elliott Hall of Music. The second one, now this is a little bit tricky here, it's Tuesday, November 8th, and that's the election day. If you can vote, you should vote. So now is a good time to figure out if you're registered outside this county, what you need to do to vote. If you're registered in this county, then you can vote, of course, anywhere in this county, on campus, in the union. But now is a good time to find out what you need to do. Now, if you're an international student, this obviously doesn't apply to you, but it's a chance for you to at least see American election around that time. It's quite exciting, I guess. Again, if you can vote, you should vote, okay? Please do vote. Final exam, date, time, location to be announced. We don't know. Once I find out, you'll be the first to know. Okay, so once again, make sure you note these 2 exam dates right now, especially the second one. Figure out what you need to do to get your voting arranged. Grades will be based on a total of 550 points. 100 points from homework, 50 points from quizzes, and the 2 midterm exams together account for 200 points. The final exam is a 200-point comprehensive final. And just like Math 161, 2, 5, and 6, there are no preset letter grade cutoffs. And of course, the cutoffs, as you know, might be familiar with, will be based on exam performance and determined at the end of the semester. Now, some rough but safe estimates are 90, 80, 70, 60. Basically, assuming that we don't curve anything. Now, if you get an A, 90, for example, you'll get an A. You won't be disappointed. If you get a B, you might get an A. But if you get an 80, you might get an A. Probably, maybe not. But you won't be too disappointed because very unlikely you will get anything lower than a B. So assume 90, 80, 70, 60 for now, and it won't disappoint you. Once again, the actual cutoffs will be determined at the end of the semester. If you consistently get below 50%, you're not doing too well, and if that continues, you won't be very happy with what you get at the end of the semester. All right? And as usual, after each exam, we'll give you the estimated grade cutoffs. Academic integrity, very simple. Please don't be a cheater. Okay? Now, I know most of you in this room will not cheat, but we all worry about somebody else in the course taking advantage of the hard work that we put in. And so Purdue University has a very, very stringent, a very strict policy on academic dishonesty. Any form of cheating, plagiarism, lying, deceiving, any of their diverse forms, such as the use of substitutes for taking exams, illegal crib, plagiarism, and copying during examinations. That includes quizzes too. Okay? Last semester, I had a student cheating during a quiz, and I confronted him with this thing. He said, "But I thought it's on the exams only." Well, I said, "Oh, come on, this is..." Anyway, this includes quizzes, okay? Exams and quizzes, just don't be a cheater. The math department does not tolerate any of these cheating. Purdue does not tolerate any of these cheating. And if you knowingly aid, abet, directly or indirectly somebody else, you're also responsible for academic dishonesty. Now, if found guilty, the penalties can be very severe. They could range anywhere from a 0 on the assignment, such as quiz, exam, a warning, a probation, all the way up to suspension or even expulsion. Now, please take a look at the academic integrity brochure I listed at the bottom here to know some of your rights and responsibilities as a student. People in the back, if you're looking for a seat, the balcony above us has plenty of seats. Okay? No need to stand. If you want to stand, that's fine, that's fine. Free country. But if you want a seat, it's upstairs. So, your lecturer, me, and your recitation TA will do everything we can to prevent cheating and uphold academic integrity standards. However, no matter how hard we try, we can't always see everything. If you witness something during exams and quizzes, please let us know. Now, in addition to that, starting this semester, you could also directly talk to the Dean of Students about academic integrity issues. So you can go to purdue.edu/ODOS. Here's a number you could call. Or you could email integrity@purdue.edu. I strongly encourage you to talk to me first before you take these steps. I want to be aware of that. And then if you choose to talk to the Dean of Students, that's fine. But I want to at least be aware of what you saw, and at the very least, I can ask my TAs to look out for future occurrences of such incidents. Okay? All right, academic adjustments for students with disabilities. Now, some of you have disabilities certified by the Office of the Dean of Students with accommodations for exams and quizzes. Now, you should have received an accommodation notification memorandum. Please take that to the Math Undergraduate Services Office. That's in Math 202, and request an information sheet for this course. Please deliver that within 1 week of you receiving that form from the DRC. And they'll tell you what you need to do about exams and quizzes and all that for this course. Now, if you're currently undergoing evaluation through the DRC, you can also request information from Math 202 to find out what you need to do once you are certified. All right, so if this applies to you and you don't understand what you need to do, please talk to me after class, and I'll help you out with all the procedures. All right, diversity. Now look around in this room. You see people from every part of the world, people from every part of every kind of background. Now, Purdue welcomes every single person, regardless of any background. So you're all welcome here. Purdue welcomes you. Math department welcomes all of you, and I welcome you. This course can be challenging, and there are many help available to you. There's the math help room that many of you are familiar with. It's in Math 211. So what happened with the math help room is that we used to have 205 and 211. And over the summer, they knocked the wall between the two rooms down. So now it's one room. Actually, it's two rooms, but it's one. So going through Math 211, that's the main entrance to that room. I can help you during my office hours, your recitation TA's office hours, and all my lectures are recorded. So I'm doing what's called boilercast, and all the lectures are recorded. Everything we're doing right now is recorded, and I normally send out a link to the lecture and the lecture notes after class every day. This semester, I think I'm going to host them, the link to the lecture and the notes on my own page. So I'll let you know how to get there after each class. But these are the resources available to you. Finally, we need to talk about campus safety and emergency preparedness. This is kind of like when you get on an airplane to fly, people talk about in case of an emergency landing, you need to do this and that, kind of like that. But please pay attention to what I'm saying here, as not like when you were on an airplane and doing other stuff. All right? So the most common sense one, if you see an emergency, you should report it, call 911. And you should sign up, if you haven't done so already, for Purdue Alert text message at purdue.edu/EA. It's a very, very useful and very, very quick way to stay up to date with any sort of emergency on campus. There are nearly 300 emergency telephones outdoor across the campus and parking garages. Those things with the blue light on them, you hit it, Purdue police picks up and asks you what you need. If you hear a fire alarm, we will immediately suspend class, evacuate the building, and proceed to the northwest portion of the Purdue Memorial Mall, near the Phoenix Sundial. I'll have a map to show you after this slide. Or Stewart Center, that's our secondary location. If you're notified of a shelter-in-place requirement for tornado warning, we stay in this room. This is the lowest level of this building. Away from windows and doors, hey, we don't have any. Look at this. We're in good place. So in case of a tornado, we're safe where we are. If you're notified of a shelter-in-place requirements for other reasons, and the alarm will sound just like the tornado siren. So tornado siren means stay indoor. Fire alarm means get the heck out. Okay? So tornado, stay indoor. Fire, out. It's very simple. Now, if we have to shelter in place for various reasons, such as civil disturbance, we will stay in this room, lock all the doors, and turn off the lights. And we will we'll monitor it for information using our computers, our cell phones, and various things, try to find out what's going on. So here's a map showing the primary and secondary evacuation locations. We are in weather row, upper right of that map. Secondary location, in case of bad weather, Stewart Center. The primary location is where that red star is. That's at the Phoenix sundial. And if that map is not to your liking, perhaps this one is. We are here. Primary location is very conveniently a Pokestop. Secondary location is in the picture in the lower right-hand corner. Okay? All right. So that's a very, very quick overview of the course. Please read through all the documents on the course webpage. Email me if you have any questions. So, now let's do some math, what we're all here for. Okay, so today we're going to actually do a very quick review of things that you already saw in the previous course. That could be Math 162 or 166. And we'll actually review 4 sections today. We're going to go very quick, and we're going to cover a lot of stuff. But it's because you have already seen this stuff if you took 162 or 166. All right, so very quickly, in 12.1, you saw the 3-dimensional coordinate system. In 3-dimensional coordinate system, remember, we specify the location of a point. Given by the x, y, and z components of that point. Very much like what you do with 2-dimensional. You tell me what x is, tell me what y is, I know where the point is. Same thing with the 3-dimensional. You tell me x, y, z, I can tell you where that point is in the reference system you give me. Much of what you know about 2-dimensional system still applies in 3-dimensional and even higher dimensional. For example, the distance between 2 points. Is from the very familiar distance formula that you know. Okay, but simply the difference of x, the difference of y, the difference of the z components, all of them squared under a radical sign. Right? You remember this stuff, I'm sure you do. And many of the shapes that you know, like circle, for example, they also have 3-dimensional analogies. For example, a sphere. A sphere with a center at H, K, and L, with radius R. So who remembers the formula for sphere? Yeah, what do you... That's the volume. That's fine, that's fine, that's cool. That's very useful knowledge to have. That's fine. But I want the formula for a sphere. Yeah. Yes, very good. Equal to r squared. Now, if you look at that, that's essentially the distance formula. This is saying that the distance on the surface of the sphere to the center is always r, right? That's the definition of a sphere. So, of course, it comes right out of the distance formula. Now what we got here, this is the standard form. In the standard form, you can always conveniently see the center and the radius just by inspection. Now, sometimes you get a sphere that's not in the standard form. For example, x squared plus y squared plus z squared is equal to 4x minus 2y plus 4. Right? That's clearly not in the standard form. All right, so who remembers how we can turn this back into the standard form? Complete a square, yes, very good. Right, so we bring everything over to the left-hand side. I'll leave that 4 over there on the right. And how do we complete a square? Let's look at the x part here. What do we do? B over 2. What's B? This one right here. Right? So that's right. You take 1/2 of this number and square that, right? And we add it to what we got. So we take minus 4 over 2 squared. Same thing with y. We look at the coefficient of this y term. It's a 2. We divide that by 2, square that, and add it to what we got already. Z is fine, so we're not going to do anything to that. Is that right? What did I leave out? Right. I did one thing to one side of the equation. I have to do the same thing to the other side. There we go. Very good. Remember that? Yes? Good. Okay, then we just finish this up. X squared minus 4x, that's a 4. Plus y squared plus 2y, that's a 1, of course. Plus z squared, that's a 4 plus 4 plus 1, that's a 9. Then we have 2 perfect squares. X minus 2, the quantity squared, plus y plus 1, the quantity squared, plus z squared is equal to 9. So what's my center? What's the center of this radius, this sphere right here? Very good. 2 minus 1, 0. And the radius? 3. Very good. We all remember this, right? Yes? Good. You should. Okay, now here's something a little bit different. What is the shape of that sphere that intersects of this sphere with the YZ plane? Okay, so we got this sphere floating in space, and then we would like to know the intersection of that sphere with the YZ plane. So what shape is that? That should be pretty easy to see. Yeah. A circle, right? If you imagine you take a tennis ball, for example, and you slice it through with any kind of plane, you know when you take it apart, you see a circle. Okay? So to find out more about that circle, first I'm just going to copy down the equation that we just got. And it intersects the YZ plane. An important thing to remember here is the YZ plane, if you look at a three-dimensional system, it's that vertical plane. So it might be, for example, the right wall in this room, and the floor could be the XY plane, for example. At the YZ plane, you can see that x is equal to 0. And so if I let x be equal to 0 in my original equation, then I can find out more about that circle. And very easily, we see that this is a circle. That's a 2, sorry, minus 2. Square that is a 4. 9 minus 4 is a 5, right? And therefore, this is a circle with a center at y is equal to minus 1, z is equal to 0, with a radius equal to radical 5. So something like that, maybe. Okay, so that's the intersection of that sphere with the YZ plane. You remember doing this, right? Yes? Okay. Now let me ask you a few questions that you might remember. If I write down the equation, let's say x is equal to 6. What is the shape of x is equal to 6 in three-dimensional coordinate system? It's a plane. Tell me more about this plane. Okay, yeah, important thing here that you got there is parallel to the YZ plane, right? It's perpendicular to the x-axis, but parallel to the YZ plane. Very good. This is a plane parallel to YZ plane. And it cuts through x is equal to 6. So, something like that. And you remember that if a number is not specified, it is understood that it will cover all the possible numbers that coordinate is allowed to have. So x is equal to 6 means I want x to be 6, and y and z can be anything that they're allowed to be. So that's how we get this entire plane here. What about this thing? What kind of shape are we talking about? Cube? Yeah, yeah. It's like it's a rectangular slab that's very, very, very wide, right? So you see here, x and z are not specified. So that means x and z are free. They can take on any value that they're allowed to have, and we're not placing any restriction on them. And we're saying that y has to be between 0, which is the x and z plane, and 4. So here's 4. And one of the hardest things about this course is actually not the formulas and all the stuff you'll learn later. It's actually sketching a 3-dimensional figure on a 2-dimensional paper. So here you see we have this slab here between y is equal to 0 and y is equal to 4. We want everything in between them, including the surfaces of 0 and 4. And x and z can take on any value they're allowed to have, which is all the real numbers in this particular example. Make sense? Good. All right, so that's a very, very quick review of 12.1. Continuing with that, again, we're going very fast today because this should be stuff that you have seen before. The point is not to reteach you this stuff. The point is try to get your memory about these things to come back, to refresh what you already know about these things. Okay, a vector. You should remember that vector is a quantity with a magnitude and a direction. For example, wind speed, right? When people say wind is southwest 25 miles per hour, you're told a magnitude and a direction. So a vector in 2-dimensional vector might look something like this, 2, 1. And remember, another way to write that is to use the three unit vectors I and j. Right? Remember seeing this? Yep. And a 3-dimensional, so this is a 2D. A 3-dimensional vector might be 1, 2, minus 3, for example. And that we often write as I plus 2j minus 3k. And the first one, the top one here, for example, this means that we go to the right by 2 units, and then we go up 1 unit. So this is 2, this is 1. And this right here, this is our vector A, 2, 1, right? So 2i means you go to the right by 2. 1j means you go up by 1. If it's negative, you go the other way. How do you find the magnitude? Let's say A1, A2, A3. Remember this? How long is this vector? Very good. Right? Sum of the squares under a square root. And this is usually denoted like that. Between 2, it's the absolute value symbol here. And we understood that that means the magnitude, the length of that vector. Of course, there's more to vectors, but for example, in 12.3, you saw the dot product. So suppose I got 2 vectors, A1, A2, A3, and B is B1, B2, and B3. How do we find the dot product of these two? Very good. So we multiply the x components together, multiply the y components together, multiply the z components together, and then add them all together. Right? Remember that? So this is A1, B1, plus A2, B2, plus A3, B3. And one thing to be very, very careful is that the dot product is a scalar. It's a number. When I perform this operation here, starting with 2 vectors with direction and magnitude, in the end I get just one number, positive or negative, but it's going to be a number, a scalar. Also, we're going to be using this formula a little bit in subsequent sections in chapter 12. And I'm sure you remember this formula. Geometrically, the dot product of these 2 vectors is the magnitude of the first one times the magnitude of the second times cosine of theta, where theta is equal to the angle between the 2 vectors. Okay, remember that? Yes? Yes. And what we also know is that we know cosine of these angles. So if A is orthogonal to B, right, then A dot B is equal to 0. Because cosine of 90 degrees is 0, right? So whenever you dot two vectors and you get a 0, you know they are perpendicular to each other. Like that, for example. Okay, so here's an example using that. We have a triangle with vertices at these 3 points. P is 1, 0, Q is 2, 3, and R is 1, 4. We can use the idea of a dot product to figure out if this triangle is a right-angled triangle. Now, if you sketch this out, it'll be very obvious why what we're about to do works. right? So P is right here. This is P. R is just a little bit above that, right here. And Q is somewhere to the right, and let's say right here. So there's my triangle. And what we can do here is to define three vectors. Let's call the vector going from P to R, we'll call that A. The vector going from P to Q, we'll call that B. And then the vector going from Q to R, we'll call that C. And now we know that if any two of these vectors, when you take the dot product of them, gives you a 0, then we must have a right-angle triangle. Just any two of these. How do I write the vector A going from P to R? Zero I plus 4j, right? I'm not going any more to the right or to the left. I'm going up 4. So what you do is you take the destination x minus the original x, that's at 0. Destination y minus the original y, and that's 4. The difference is how much you have to move. And similarly, b is, I want to go to 2, I have a 1. The difference is 1. I want to go to 3, I have 0. The difference is 3. So I need to add 1 to the right and 3 up. C going from Q to R is equal to -1, +1. So now we know if dot product of any two is 0, then that triangle must be a right-angle triangle. Okay? Now the dot product of these three is very, very simple to do. I'll leave that to you to try out on your own to see if this is a right-angle triangle. Okay, last but not least, this is 12.4. The other kind of product, the cross product. Suppose we got two vectors. A is equal to 1, 0, 2. B is -3, -1, 2. And we want to know what A cross B is. Okay, who remembers how to do this? From 162/166, yes. Right, the determinant. In the first row, we put our I, J, K. And then the second row here is the first vector in the operation. So A is first, so A goes into the second row. B is last, B goes into the third row. All right, remember how to do this, the determinant? Raise your hand if you remember. Very good. In case you don't, for the first one, you cover up the first row and the first column, and you take the determinant of what's left. So here, determinant is 0 minus 2. That's a +2. So this is a 2i Now, what's this something special we have to do with the j component? Very good. We have to change the sign. So I'm going to put a minus here, cover up the first row and the second column, and take the determinant of that. That's a 2 plus 6. That's 8, right? So normally it's 8, but we got to switch the sign. Remember to always switch the sign for j. And then the k component is minus 1. That's it. So minus 1k. Or 2 negative 8 minus 1. And geometrically, what does this vector look like in relation to a and b? Perpendicular. Very good. So a cross b is always perpendicular to a and b. Also, you remember this. The magnitude of a cross b gives you the area of this parallelogram. Right? Remember that? You do a cross b, it gives you the area of the parallelogram defined by a and b. All right? Okay, that's all the time we got. Now, there's a little bit more to these things, but as you start working on the homework, memory will come back to you on these things. All right, that's it. See you again on Wednesday.
Hello.